Okay, thank you very much for the introduction. Does anybody have an opinion about how long this talk should take? I can set my timer until midnight. Any opinions how long it should take? Half an hour or something? Or
20 minutes.
20 minutes? Okay, that will be the compressed version. That's
You can take more, that's fine.
let's go for 25. I hear 20, I hear half an hour, we'll go for 25. So thank you for the introduction, and thank you very much for inviting me here. I appreciate it very much. Before I start the actual talk, I'm going to abuse this opportunity to make a 60-second advertisement. So in June of 2026, we are hosting the annual Euroviz conference. Has anybody ever heard of Euroviz before? So Euroviz is the premier European conference on data visualization and explainable AI. And it only comes to the UK every 10 years approximately. So the last time it was in the UK is in 2014 in Swansea, Wales. Before that it was 2005 in Leeds, actually. So once approximately a decade it comes to the UK. So I encourage everybody here to consider participating. You're welcome to come and participate, or we're looking for anybody that's interested in getting involved as well as part of the organization. And this is the webpage, euroviz.org.uk, and actually you can already register if you want. So if you have some funding that's about to run out and you don't know what to do with the leftover money, you want to register early, this is a great opportunity to do so. Okay, so this talk is different. It's not me standing up and saying, here's the stuff that I worked on, or this is the research that I'm working on, here are the research projects. That's not what this talk is. It's a little bit different. It's more of like an editorial or a viewpoint. It's me kind of expressing some opinions, which means it's not quite as scientific as maybe some of the other talks. The other thing I will mention is if you have any comments or questions, feel free to interrupt in the middle. You don't have to wait until the end to maybe agree with me or disagree with me or make some comments. So it kind of starts off with me and a PhD candidate, a conversation between me and a PhD candidate. I was reviewing a PhD candidate's research paper. And usually when I'm looking at the research paper, I always want an overview. And this paper was missing an overview. And so the feedback I gave was this paper would benefit greatly from an overview of the method, right, before getting into the details. And his response was, I don't see the value in that. And it just stuck with me. That response stuck with me, and I just thought, how is that possible that you can't see the value of an overview? That seemed impossible to me. So that's kind of the inspiration behind this viewpoint or talk. So it's expressing the value of overviews. That's essentially what I'm doing here. And this is also coming from a data visualization perspective. So this is not an AI talk necessarily. It's one of the rare talks nowadays that's not about AI. But it is connected to AI if you use your imagination. Has anybody heard of the visualization mantra before? Overview first, zoom and filter, details on demand. Anybody ever heard of that?
Yeah, I do teach to students.
Very good, very good. This is not only an overview. A mantra for visualization. I think this is a mantra for everything, actually. No matter what you're doing, It doesn't really matter what you're doing. You want an overview first of whatever challenge you're facing. Then you want the options to filter and select, and then you want details on demand. It doesn't really only apply to data visualization. But the overviews we're talking about today are directly corresponding to this overview first part of the visualization mantra. And in my opinion, overviews are like the Holy Grail of data visualization. This is our job as data visualization scientists, to come up with good overviews. Why is that our job? It's because overviews are the most important aspect of data visualization. They're the most in demand. They're the most challenging. And they're the most inspiring and interesting as research challenges to create an overview of special data sets. So the importance of overviews cannot be overstated, and that's what we're going to talk about for the next 19 or so minutes. Why overviews? So one of the hypotheses of this talk is that overviews are in very high demand. And this is based on experience. So one of the projects we worked on was with a company called QPC. Has anybody ever heard of QPC before? They're based in Birmingham. It's a small company, so I wouldn't expect anybody to hear about it. But QPC is a company that develops database software. And the database software is recording every event inside of a call center. And when you think about it, call centers have a lot of events inside of them. So they record every time a person calls, the phone number calling, the time at which the call takes place, the different menu options that the caller selects in the IVR, the amount of time that every caller waits before speaking to an agent, which agent they spoke to, how long they spoke to an agent for. But it gets more complicated. A lot of times the agents will put a caller on hold and then call another agent and then have a conversation with another agent and return to the original caller. Sometimes the caller will get passed from one agent to another. So I think we all know about call centers from the caller perspective, right? Because this is one of our favorite activities, like calling call centers. And one of the first things that QPC ever said to us, they said, we think that data visualization can help us understand what's going on in the call centers. And one of the first things they said was, we just want to know what happened. They didn't use the word overview, but they said, we record all these events, say hundreds of thousands of events every single day in a call center, and we just want to know what happened in the call center that day. And we noticed, they tried some visualization of their data, but we noticed, they can't get an overview of their data. They cannot generate an overview. So our question was, how is it possible to generate an overview of hundreds of thousands of events inside of a call center? How is that possible? So I have an example attempt at the generating an overview. So this was a collaboration with QPC in Birmingham. And what we're going to look at here is one day in the life of a call center. And there are several 100,000 events during that day. And there are thousands of agents working on the call center. So we generated an overview using a tree map, right? And we can see one of the objectives of the call center is call resolution. So in this case, the tree map has 24 squares, and each square represents 1 hour in the day. And then inside of each square is another square that is mapped to the number of calls that the call center receives in that hour. So you can see when the call center is closed, it still receives calls, but it receives quite a small number of calls. And then around 8 or 9 a.m., the number of calls ramps up. Now in this case, the color is mapped to the length of the calls. So you can get an overview right away, and you can see that the length of the calls increases during the evenings. So right around 7 to 8 p.m., the length of the call increases significantly, which implies that the call center is short on staff during those times. Now, one of the other things is we have a lot of different filtering and selection techniques, and the user can click on any hour and then zoom in to see more details, right? Every hour is divided up into different chunks of about 10 minutes, and then those inside of those chunks of minutes, you can get individual phone calls. So like this is an individual phone call, and it sticks out because it's very long. And that's one of the ways we tried to provide an overview for QPC. And we have this special zooming, panning, and filtering techniques. So the user can start with the overview, they can choose an hour that they want more details on, and they can make a smooth transition to zoom in on any given hour. And then if they hover their mouse over an individual call, they'll get the actual call record, like the details of the individual call. But it helps facilitate patterns. And when we showed this to QPC, this was the very first time anybody had ever shown them an overview of their data. It was the first time. And one of the things they noticed was that half of all the calls in the call center are generated inside the call center. So in other words, they double their own work by making lots of calls inside the call center. And the reason for this is usually because the callers end up with the wrong agent. So they need to transfer the call. And I think from experience, everybody has had that happen where you get a cold transfer from one agent to the next. How exciting that is. That might seem very niche, but this example has extreme implications because the number of people employed in call centers is in the millions all across the globe. So if you can make small incremental improvements to call centers, you can have quite a dramatic effect, because call centers employ a huge percentage of the population, including in the UK. It's something like 3 or 4% of all working adults work in a call center. It's a huge population that you can affect by improving the call center experience. Okay. Let's see if I can go.
We present Agent Viz, an application for the visual analysis.
So that was an attempt to visualize or obtain an overview of the activity inside of a call center from a caller perspective. So that was all the data centered around the individual calls. This is a different view of the call center activity from the agent perspective. So this is another visualization technique that's trying to provide some sort of overview of the activity in a call center centered around the agents working there. So the question is, how is it possible, again, to get an overview of all that activity, those hundreds of thousands of calls centered around agents that are working in the center? This is a different PhD student, by the way. And so we started out with a simple scatter plot. And the axes on the scatter plot are, in this case, this is the average customer effort score. and this one is the average net promoter score. But the data set has a lot of different variates, right? Average net promoter score, the average cost of every call, the total cost of every call, and so on. There are many different dimensions to this agent data set. Each ellipse represents one agent, and then they're color-coded by the department that they work in. And what's very interesting in this perspective is outliers stick out quite easily. So here we have a very, very strange agent that puts all of their calls on hold, right? It's like some rogue agent. So this is the kind of agent you might want to terminate from the call center. Actually, I think that's not a real agent. I think that's either a bug in the software or a bug in the data, or one or the other. So we can represent every agent with a glyph, and then we can add different dimensions to the glyph, like the number of transfers the agent makes, the average net promoter score. That means like the average customer rating score. Customers are allowed to send feedback and give ratings to their customer experience. And yeah, we can also see some more outlier agents that love to put all their callers on hold, right? But one of the problems with this overview, can anybody see a problem with that overview? It overlaps, yeah. There's occlusion, and there's a lot of crowding along these this quartile of the Cartesian plot. So we can use scaling, for example, to alleviate some of that. But we also thought, well, maybe there's a better way to address the overlap and the occlusion, and so we designed a hierarchical clustering technique for agent glyphs, for multi-attribute agent glyphs. And that's one way we attempted to provide an overview of the data set. So this is what we first saw was the unclustered version, and then we have different clustering parameters that put groups of agents together in a common cluster, and represented by a glyph with a number at the center that indicates the actual number of agents being represented. And then if you hover over any glyph, you get the details, like how many agents are in there, the average net promoter score, the average number of the average cost of each call, and so on. And the user can zoom in and out of the scatter plot and get more detail. So as they zoom in, the clusters subdivide and provide more detail. And when they zoom out, the clusters reformulate and represent a higher level of abstraction to address this occlusion. This was the first kind of visualization that the QPC ever saw of the agent side of the equation.
We present agent viz.
This is a completely different application. It's from computational fluid dynamics. Anybody here familiar with computational fluid dynamics or worked in computational fluid dynamics? Anybody know what that is? It's an area of engineering that tries to predict the behavior of fluid flow as it interacts with the environment, but usually surfaces. So it's a big area in engineering. And we have done work on visualization of computational fluid dynamics data. And one of the experts that we worked in with Jürgen Schneider said, we always start by examining the surface in an attempt to get an overview of the flow. So we tried to develop some flow visualization technique that provides an overview of the flow at the surface. So this is computational flow. And we tried to do that using texture, something we call texture advection. So we texture map the surface. In this case, the texture is a kind of pink noise. It's not pure white noise, but it's a kind of pink noise. So we texture map the surface with pink noise, and you can see that the texture is changing over time. So it has a temporal frequency and a spatial frequency. And then we advect or push the texture in the direction of the flow at the surface. So that's something we call image space advection. And this is a video that tries to convey and demonstrate how the process works. So it has different stages. So it has a clipping stage that makes the edges, the round edges, nice and smooth, and that's what this part of the video is trying to demonstrate. It has an overlay, a so-called overlay phase, where we show the surface itself and the opacity of that surface. You can change and adjust the opacity. So this is putting all the different steps together, the vector field, the noise injection, and all the different components, showing them as they add up one after the other. And then this is showing what the texture advection looks like in different application scenarios. Right? So this is a very common example of flow past a block. If you've ever looked at any flow visualization literature, this is a kind of classic scenario where studying the flow as it passes a block. This is the same idea, but with a velocity mask. So the velocity mask highlights areas of low velocity. Right? That's what the velocity mask does. This is showing one of the parameters of the algorithm, which is the resolution of the noise that's used to inject the texture. This is using the technique to visualize the flow at the surface of an aneurysm. So it's not only automotive engineering, but also medical engineering. So CFD and medical engineering overlap, especially in the area of blood flow. Okay, those are all examples of what I would call successful attempts at providing an overview of very large, complicated data sets. Just for the fun of it, I'm going to be one of those rare instances where I show an unsuccessful example of an overview. We tried a project with some marine biologists, and the marine biologists are trying to study the behavior of deep sea wildlife. And one of the ways they try to understand the behavior of deep sea wildlife is by attaching digital sensors to them. So they will go out into the wild, capture the wildlife, and then actually put a digital sensor onto the wildlife, like a turtle or a penguin or a cormorant, release it. Whatever it is will typically swim at great depths, and then they will recapture the animal either a few hours later or a few days later, take the digital sensor off, bring it back to the laboratory, and try to figure out what the animal did during that time. And those sensors, they record different properties of the local environment, like triaxial acceleration. They record local pressure, they record local temperature, and local ultraviolet light. So the scientists, the marine biologists, recollect the sensors and spend days browsing this time series data. And we spent a long time trying to figure out how to visualize this data. And one of the nagging questions in my mind the whole time, although I didn't think of it exactly in this formulation at the time, But the whole time I was wondering, how do we get an overview of this data? How do you get an overview of days worth of time series data? If you just take the time series data and you plot it on a line graph, that line graph will wrap around this room several times, right? It will be a very, very long line graph. And we tried different ways to visualize the data. So for example, instead of using the classic time series plot, this is triaxial acceleration plotted over time. So each one of these axes is one of the X, Y, and Z components of the accelerometer data. So all we did was we reconstructed it in a polar coordinate system. So you can see, now suddenly you can see the actual orientation of the animal in a more natural space, right? And if you combine that with pressure data, you can actually visualize the descent of an animal, its swimming underwater, the hunting activity, more swimming, and then the ascent back to the surface. But as good as this project was, and as we could infer new behavior and new analysis from the data visualization, we never really successfully got an overview of the data. In my opinion, we never succeeded in this. Okay, so the 25 minutes are up. I will do a very quick summary of the rest. There is more, but we'll, in the interest of time and keeping to the schedule. So some of the common themes from all these collaborations was everybody, if you listen very, very carefully to any domain expert collecting data, the first thing they will say, or one of the first things they will say, is we simply want to know what happened. Like, we've collected all this data and we don't really know what happened. And in my opinion, this generalizes to, we would like an overview of the data we collected. This is the translation from a data scientist point of view. There's a popular visualization technique called line integral convolution. It's very, very popular, very highly cited. Why? It's because it provides a detailed overview of vector fields. There's a popular visualization technique called tree maps, right? Very, very popular. This is a very, very popular tree map viewed by millions of people every day. Why? It's because tree maps provide a scalable overview. That's why they're so popular. Another popular visualization technique is edge bundling. Edge bundling is popular because it provides an overview of relationships. Volume rendering is very popular because it provides an overview and details at the same time of your medical data. Parallel coordinates are popular because they provide an overview. Maybe you've seen these techniques before, maybe you haven't. But if you look into the visualization literature, you'll find these are the most popular ones. And I'm saying the reason they're so popular is because they're so effective at providing overviews. Dashboards are popular. And the reason they're popular is because it's an attempt to provide an overview of the data. It's not very good, in my opinion, but this is the reason they're popular. Survey papers are popular because they provide an overview of the research literature, the overview that everybody wants. And then I was going to wrap up with properties of good overviews. The condensed versions is a good overview makes good use of screen space. This is one example. I would visit the website and show you the demo, and if this was the extended version of the talk. A good overview is scalable. In other words, you can increase the size of the underlying data set and the overview will still work. It won't break. It will still be effective. We won't go into that example. A good overview also shows relationships between data attributes. So that's another property of a good overview. Okay, and that's the summary. Overviews are the holy grail of visualization. They're the most important. They are the most in demand. They're the most interesting, and they're the most challenging, and therefore offer a great source of inspiration. And then we have some properties of good overviews. That's my Euroviz advertisement. I moved that to the front just before everybody fell asleep. Any questions?
Thank you, Robert, for very useful information. Any questions, please?
Yep.
First of all, nice presentation. Just want to ask from a machine learning point of view. So I understood the importance of overview and how you go into a more granular way of data. How do you feel from a machine learning point of view? We always work with vectors and matrices of high dimension, and sometimes when we need to analyze those data, we reduce it to a very low dimension, to maybe to a 2D scatter plot or a 3D scatter plot using some statistical mechanism, but that reduce the actual representation. So how do you think that the technique of you, how you work with several problems, can be used to visualize high dimensional data to represent, okay, what kind of clustering can you make, or what that data indicates?
So if I understand the question is, how would I visualize high dimensional data so we don't have to do the dimensionality reduction that's so difficult to interpret?
Yeah.
Well, what the most obvious suggestion would be the parallel coordinates. So this shows an example of a high dimensional visualization technique called parallel coordinates. So instead of reducing or projecting down any dimensions, we preserve all the data dimensions. And then we provide each data dimension with its own axis. So this is the same data set as that we worked on with the marine biologists, right? It has pressure, it has the acceleration along y, the acceleration along x, the acceleration along z, the depth, the infrared, the mouth sensor, the local temperature, and even the accelerometer from another sensor. And you can plot all of these data variants side by side and explore the relationships between them in this kind of visual design. So this is one response. There are other high dimensional visualization techniques, but this is sort of one of the classic ones, I would say. And what we did is we tried to make it more scalable. One of the problems with parallel coordinates is the overplotting when the data set gets too large. So we try to enhance that with these things called angular histograms to make them more scalable. Yeah.
Yes. And
Other questions?
Got a related question.
Yep.
Has there been work on, if I provide a large data set, new data set that hasn't been seen before, automatically picking an appropriate overview, not only showing the technique but also picking the appropriate dimensions so that something interesting pops out. In the case of the call center, you honed in on the particular things that had interesting observations to make, the length of the call late in the evening. So you picked out length and time of day.
Yeah.
So
There's a lot of pre-processing. So
a lot of pre-processing to get
yes.
to that stage. Yeah.
So I think that's a great question, and I would say that's an unsolved problem. Providing an automatic overview, I guess it's definitely possible to provide an automatic overview. The question is, how good can you make it? So it's not difficult to imagine providing a histogram of any data set. And that's going to be very helpful, by the way. Like providing a histogram of any data set automatically providing scatter plots of the data set automatically is also going to be very helpful and interesting. But what I would go for in the simplest case would be a histogram of every variable in the data set and a scatter plot matrix of the data set. Those would be two kind of feasible and fully automatic possibilities. And then the question is, how can you get something better than that? Like, what can you do that goes beyond that and that's better? Like, we do have a project called automatic visualization that addresses exactly what you're talking about. Yeah. And it's a good problem. It's a great problem. Another question?
Now that clearly deep learning, artificial intelligence are ongoing. So have you seen or have you done something like how to visualize essentially what's going on in the neural networks or in the deep learning models?
Yes, so the best answer to this question is go to Euroviz 2026. If you attend Euroviz 2026, you will see hundreds of people presenting visible AI techniques. Like they'll be talking about visible machine learning and visible AI techniques all the time. So that's the best answer. So there are a lot of people working on this.
Normally there's two kinds of like programming techniques. Yes. One is about like the called TSNE.
Yes, yeah,
Another one
the
is,
Disney.
yeah,
Yeah.
class activation function or something.
Yes, yep.
That's widely used. But then clearly a lot of features have been like extracted by the networks or the models.
Yeah. Yeah.
Is there any work ongoing about how to visualize that kind of features?
Oh, definitely. There's a lot. And one of the challenges is keeping up. Like, how do you keep up with all the new papers on these topics? That's one of the big challenges. And right now in the Viz community, there's a massive wave of papers being written and submitted for review right now on visible LLMs. How do you visualize the properties of LLMs? This is a huge, I have a stack of papers on my desk just dedicated to this topic, under review right now. Some of them are quite good, and some of them are not so good. But yeah, if Euroviz is your answer to this question, like you'll have a great time, Yeah. Paul, I expect you to see Euroviz.
Quick please, then we'll move to
Okay,
the
well,
next
just
question.
quickly, so I take your point regarding overview, but I'm not totally convinced about parallel coordinates. As you know, we had a little go at them some years back.
Yeah, I
I
remember.
think, would you say compared to tree maps and edge bundling, are they as popular really? In the general community, not the purely Viz community.
Oh, you mean beyond the Viz community?
Yes.
Oh, that's a good question. So tree maps, I would say, definitely have penetrated the broader, the rest of the world.
Edge bundling you see also quite often in various, popular science type places.
Yeah. I would say there is a Viz paper. It's called on visualization literacy, and one of the results from that paper is they surveyed all the textbooks, news articles, like all textbooks used in schools, or let's say the most popular ones, the most popular news sources, the most popular magazines, and they tried to find out what are the most common visual designs. And parallel coordinates was not in there. So it's not in the top 12. I can say that with a lot of confidence. But you're not the first person to say that. So I think the best answer is I don't know. They haven't really penetrated the mainstream, and they're not very popular outside the Viz community.
So what would you say would be your top 5?
The top 5, you mean beyond just pie charts and line charts and things
Just
like
your,
that?
if I asked you what your favorites.
Well, one of my favorite overview techniques is the tree map for sure, because it's scalable. So you can zoom in up and down the tree map hierarchy and arbitrary levels of detail. So it applies to almost everything. So that's one of my favorite generic overview techniques. I do like parallel coordinates personally, but I can see the skepticism behind them, and I can see the scalability problem or the scalability challenge with them. Scatter plot matrices, I quite like scatter plot matrices as an overview. And scatter plots as well, if it's a lower dimensional data. Did I miss anything? Of course, for the flow visualization example, I like the texture-based flow visualization technique. There's a lot of bias in that, of course. But those are some of my favorites.
That's it, right?
Question. Thank you for still being awake after such a long.
Yeah, thank you very much.
Thank you very
So.